Welcome to Study Loop.
So here for part A, we can calculate the gauge pressure. We can say the atmospheric pressure, or P initial, would be equal to the pressure of the air, so the atmosphere, and then P minus P sub A would be equaling to the density times G times H. This would be the gauge pressure, and this would be 1,000 kilograms per cubic meter, the density of water, multiplied by 9.8 meters per second squared, multiplied by 0.150 meters, and we are getting that the gauge pressure is 1,470 pascals. This would be our answer for part A. For part B, then, we know that the pressure at point 1 equals the pressure at point 2, so we're going to apply equation 12.6, and we're going to apply this to the right-hand arm of the tube and then solve for the height h. So we can say P sub 1 would be equaling to P sub A plus the density of water times G multiplied by 0.150 meters. And we know that P sub 2 is equaling the pressure at A plus the density of mercury times G multiplied by 0.150 meters minus H. And we're going to then solve for H. Knowing that P sub 1 equals P sub 2, we can get that the density of the water times G multiplied by 0.150 meters equals the density of mercury times G multiplied by 0.150 meters minus H. Of course, here the gravity will cancel out, and we have that H. We can say 0.150 meters minus H. This is going to be equaling the density of water, 1,000 kilograms per meter cubed, multiplied by 0.150 meters, divided by the density of mercury, 13.6 times 10 to the third kilograms per cubic meter, and we find that this is equaling 0.011 meter. So essentially, the height of H would be equal to 0.139 meters. This would be our answer for H. That is the end of the solution. Thank you for watching.